Hello and welcome to another video. So this is a little bit different to the tutorials that I've normally done, and it's something new that I wanted to try out of taking a look at previous projects that I've built, sharing some of the code for those, and talking through a little bit about sort of the design process, also the actual technical implementation. That's parts of the code that I'll actually share, and sort of looking at things that I would do differently next time. So let's dive on in and let's take a look at one of those projects. This is one of the very early ones that I did. So with this one, it was one that the total development time, so not the actual time between starting and finishing, but the actual amount of hours spent was just under 24 hours. It was a challenge I was sort of setting for myself with a series of different ones. So the idea behind this one is that you are in detention and you are having to solve math problems, and the problems get more complex over time. And it's basically the goal is to see how long you can keep actually playing it for. That's really the entirety of the goal. So I can't share the full code for the project because there's some middleware that I use that I don't have permission to actually be distributing that. So this is something where it is, I'll be able to share snippets and key sections of the code there. So I'll be putting those up on Git for folks. So let's take a look at sort of what the gameplay of it actually involves initially. So we'll run it. So actually kind of surprised and pretty impressed that this last time I opened up this project it was Unity 2019, I think 0.2. And surprisingly, it loading it up in 2023.1. I didn't have to fix any errors. There's a few things that it's grumpy at me about, but no errors that I needed to fix. So this was very early in the series of projects that I made. I didn't have a standardized main menu or anything like of that. For doing like of this, there is no Cinemachine, anything like of that being used. I've got manually placed sort of camera markers and things like of that. And so here's an example of sort of the problems. And it would keep this little tally on the side there, which is really easy to miss. I think the other problem, like in terms of with design of it that I don't like, is it doesn't automatically select the thing to actually be typing in. So I have to go and manually type in once. It's surprisingly robust for actually being able to handle some fairly complicated problems, but the way that I did that was definitely a little bit sort of it was exactly what you would expect for a project that was done very quickly. There's no penalty for failing to solve for getting an answer to a problem incorrect. So you do get a penalty if you fail to solve one. So the cat Schrodinger, which design choice. The reason the cat is in the box is because I couldn't find a sufficiently rigged and animated cat model that was just easily available that I could slot in the very tiny amount of time I had for this. So it's basically I figured put it in a box, and it's like, well, if it's a cat in a box, of course I'm going to have to call it Schrodinger. So definitely a bit more of a colorful way of solving the problem. But this is one of the things with games. You don't always need to solve every problem, and sometimes you can actually, as in this case, by making a design, a visual choice, you end up with something that I think is actually better than if I had a cat model. Like, I had my doubts leading up to it of whether this was going to work, but I actually did like it a lot better with the cat in the box. Obviously, don't put a pet in a box or a non-pet in a box. So as it continues, Schrödinger gets progressively more frustrated with your inability to solve the problems. And they do ramp up. You do get multiplication. I intentionally didn't have division because I didn't want to have to deal with non-integer numbers. That was a very, very deliberate choice. And so then when you eventually fail, well, I probably need to adjust the speed of that. But in terms of how a lot of things work, if we take a look at sort of the anatomy of the scene here, a lot of stuff is fairly unsurprising. I didn't build most of these assets. I think the walls I did build, and the shelf maybe I think was one that I built. Shelf that looks actually like no. Oh no, it was a Pro Builder one, so yes, that would have been one that I built then. But the rest of these are all assets that I got. They're all a low poly pack that I purchased, so obviously I can't distribute the assets there. But in terms of how a lot of things worked for this, there was a lot of stuff with these camera markers. And so because at this point I hadn't had any experience with using Cinemachine and Timeline, so again, from a technical implementation point of view, that's something that in later ones I did very differently. And if I was revisiting this again, I would do it significantly differently. And in particular, main thing I would use was Cinemachine and use Timeline for doing all of these transitions. Having manual individual markers for all of these things was just like, it worked and it was a quick and easy thing to implement. But if I had known, because like all of these things, the credits are on the ceiling. So if I had known other ways of doing this, I would have done that. It was very early in me doing a lot of these projects. So there's a lot of bits there that are sort of, not great. There was also a lot of stuff I had to do with positioning the box so it was always on screen. So there was a lot of conversions that were happening there in terms of being able to have those marker points actually get positioned properly. So I believe with all of that, what I ended up doing was, so yeah, there was a lot to all of this stuff. And I'm going to guess this is probably one where I, in the game manager had a lot more stuff than I think I would have these days. I think there's not too much code there, but I think it's definitely messier than I would have liked with it. If we take a look at what the actual camera transitioning stuff is doing, has a bunch of ones configured here. So essentially what I've ended up doing here is a not great and more complicated version of Timeline and Cinemachine. So it has these transitions that have marker points in that configured. This might still be useful if you're wanting to avoid using Cinemachine or Timeline, or there might be a reason you can't. I think this is something where also, if I had used things like lean tween, something like that would have made my life a lot easier. But this is part of the code I will make available. The game manager is not particularly useful, but this camera transitioner I think is a useful one because it does show what sort of is happening behind the scenes of something like a timeline or something like, lean tween, how that process actually happens. And while I wouldn't generally use this in future because I heavily make use of Cinemachine and Timeline, I think it is a setup that worked quite well and really illustrates sort of quite nicely how to actually work with stuff. Splitting out the curves for position and rotation really gave me a lot of control there. over how smoothly those things transition. I don't know if I ended up actually doing anything different for any of them, though. And it just keeps collapsing annoyingly. So, because it won't properly recollapse. So I think all of them look pretty similar. It is some slight differences with some of these ones, but it was basically setting the markers, and it could do things like pausing and unpausing. So there was a lot of different bits and pieces in there. But the major part was this problem generator, and in terms of how this actually worked. So this is one that I definitely would do again differently. The way that it worked was I could define these different problem definitions. I had a scriptable object that was my database of them. And then I had separate tiers. And so these would have, I think, they link to the UI prefab. So this structure, all of these, essentially the only difference between them is the enum. So it was one of those things where it was a process of, I laid this out. It seemed like a logical thing of splitting these out into separate tiers, having those as a separate scriptable object. But in the end, this data here is really just every element in the enum, and I never ended up tuning these because it didn't end up making sense to. So that was something where if I'd done a bit more planning beforehand, I think I would have spotted that problem. It was something where I didn't really spot the problem until I was a fair chunk of the way through implementation, and then I couldn't afford the time to change it. So a little bit of planning would have made it better there. I would have probably had a much simpler code setup. Because if we take a look at what's in these problem definitions, so this is in terms of how they actually worked. And again, like I encoded a lot of stuff into this enum. So my way of structuring it was the particular tier really, it did correspond to a level of difficulty, but it really, what that difficulty manifested as was whether you were getting multiplications in there, how many sort of variables were going in there, and the combination of different ones. So how much it was mixing and matching different things. And this worked okay. And given the time constraints that I had, this was a reasonable approach for being able to have something where you could have variation in the problems while also still having a scaling level of complexity. I think I did end up, with this, it really did limit it. Now, if I had more time, if I was doing this again, there's a couple of ways that I would look about going at handling this sort of differently. So one option, the very, very full-on one, would be something where it is able to kind of, do a general sort of rough calculator logic, being able to parse a mathematical expression and then interpret that. Now that's one approach, and there's actually some really nifty ways that you can do that with C#, like generating code and runtime compiling and linking it. I haven't tried out to see if that works in a build or on mobile. Mobile, I think, might be an issue there with that. Wouldn't surprise me. And you also potentially would run into App Store issues, at least with Apple, because of the dynamic nature there. So I think that would be an approach, but probably not what I would do for something if I was wanting it to run on a lot of devices. I think what I would do is I would actually build sort of essentially a very limited instruction set of scriptable objects. So having things like, okay, you have, a variable object. You have a operator object, and here are the possible ones that it can be. And supporting things like, well, here's a parentheses operator. or a parentheses object, and then the parentheses one can contain other things. So being able to build up essentially an expression that it's going to be a nested set of these individual elements, I think that would have allowed me to far more quickly build up a database of these and a wider variety of ones. And I think would also open up being able to, I think, procedurally generate those. I think would have been much more doable with something like of that. Plus, also evaluating them could evaluate anything. So that's one of the big things that I would change going forward. Is I would actually set this up so I've got that limited language. I don't think it would actually be too involved to set it up. Once you've got it set up, it's then a really usable thing that you can adapt to a lot of different scenarios. So I think that would have been a much better setup than what I ended up going with here. Because a lot of this, this is very manual, very hard-coded for stuff. I'm pulling things out in terms of, it gets a list of values and a list of plus-minus operators. Not a good set. And these are using, well, yep, there's very strict limits with what tiers can use what values. These are magic numbers. These are hard-coded values. If I went and modified something here, I need to remember and go and modify it here and also down here and change how things get evaluated. It's not a good setup. This is actually, I think, I will include this code because I think it's useful to be able to see, honestly, a bad way of setting it up. But I think also then gives you an example for, I think, the problem generator side I did quite like in terms of how it sort of scales up with difficulty. So what it would do is it had this process for getting the next problem. And it would take a look and see what our current one was. It would take a look at the repeat count. And after we'd repeated a particular sort of set of problem a certain number of times, it would increase the actual problem that's being generated. So it would go and step through to the next one. And it would also advance the complexity. So that was also a big thing as well, that I wanted to be able to say, and we can look at the setup on the actual database itself. So problems will repeat 3 times. The solve time gets reduced, and I have our starting solve time essentially, and then the minimum, so the lowest it will ever get to. So the idea was, over time, the problems get more complicated, and you actually have less time to solve them. So once it had hit the repeats, it would advance to the next level. Once it hit, having cycled through all of the tiers, then we'd reset back to the start. We would also then lower the solve time, and it would prevent it. Again, that I could have done a clamp or a max would have been better. Now, when it was instantiating the problems, and again, this hard-coded, this is not a nice setup for it. And yeah, I think in hindsight, all of this stuff of how it actually generates and structures the problems, I think was not good. So the other thing I did with this in terms of complexity, because you've got multiple aspects to complexity. You've got the time pressure, you've got the complexity of the equation itself, and then the range of the values. So the range for the values could scale up. So what I did was even ones always could use that large range, whereas odd loop sort of sets, what they would do is you would have a 50-50 chance of it being that large range or being a much more friendly range. So that worked out quite nicely. It does get up to, after a while of being double digits and you have very limited time. Worked quite nicely. And it did make for a fairly straightforward setup, because it just needed to generate these. It could essentially run infinitely. It would just get continually more and more complex, but there would always be a set minimum time. It would never get to the point where a problem would be failed before you actually, it's properly appeared. And that was an important thing. I didn't want it to, get to a point where it couldn't actually be solvable. I did seed the random number generator like this so that it wasn't always the same values that were going through, so that you did actually get to see different ones occurring there. And then in terms of with the problems themselves, those were actually pretty straightforward. So the UI itself, if we take a look at it, to make it fall down nicely, I just gave it a 2D collider and put a rigid body 2D on it. And there is actually a collider at the bottom there. It was the easiest way to actually make them stack. And this is one of the things, when you're doing stuff with games, you might look at something like this, so you want these problems falling down. How do I make it so it'll work nicely? In particular, if you get multiple ones stacked up and you solve one, you want everything to fall down. How to go about doing that? Don't overthink it. Consider the simple options like physics. And just because you're in a 3D game doesn't mean you can't have something that is running in 2D physics like this. So this is fully using 2D physics for the only part of it that has physics. And if we catch when a problem falls down, now that we know that, because one of the nice things that you get as a result of using physics is you get it starting at this low speed and it ramps up. And so it lands quite solidly, which is really good. And that worked quite nicely. I really like that sort of behavior with it. So always keep that in mind. You're not restricted to having to use only 3D physics because you're in a 3D game. You can use 2D physics. Perfectly valid. And the problem UI itself didn't really need to do too much. It had some stuff there for a little bit of delayed destruction. It did detect when it actually collided with something. And this was a really important thing. This was intentional to only start the problem if it hadn't been started and it was currently falling down. But as soon as it hit the actual base, that problem would start. So that actually worked quite nicely. Again, taking advantage of physics to handle that cleanup. So it worked quite well. So I was happy with sort of the overall effect of the game. Like, it did end up working the way that I sort of intended. It was intended to be a first very simple game and made under a very, very tightly constrained time pressure. So I was trying to keep something super, super focused there. And it did achieve that goal. It was something that was very focused, was easy to get up and running. I think the big areas where it fell down was because I didn't know anything about Cinemachine and Timeline. I ended up having to set up a whole bunch of transition logic, and there was a lot of fine-tuning of that. That was really frustrating to actually do. And also the problem side of things, having that very fixed set of tiers that it worked between. Again, it made it easy in the moment. But in hindsight, I actually think it probably wouldn't have taken too much longer to set up that expression system. And that might be something that I'll actually do at some point as a separate project, is build up that expression system. Because I think that could be a useful thing to talk through the process of how I'd go about that, and especially seeing a way of doing it that I really didn't like. I think, yeah, in hindsight, I would have done that quite differently, and I think it would have worked out a lot better if I had gone for that approach. But I will make all of these bits of the code available for it. So pretty much these 5 ones. So the problem side of things, the 4 files for that, and the camera transitioner. They're the ones that are doing most of the logic. And I think have the most interesting bits there to see in it. So I will put those up on GitHub. There will be a link to that in the description. And although this isn't something I'm releasing as a tutorial, these parts of the code, completely like with all of my other ones, you can use those in any of your own projects, and no restrictions there, commercial, non-commercial ones, completely fine to be using those in anything at all. So dive in and experiment with it. Like, see if there are bits of that code that could be useful to you, or have a go if you're wanting to and implementing your own setup for doing the problem equation sort of system that I had for this. I think it's a really fun area to implement, and it's also an area that really forces you to think a lot about maths and how to structure things so it's clear and the evaluation of it. So I think it can be quite an interesting exercise in that regard. So dive on in and experiment and see what you can do. Thanks, folks. Hope you found the video interesting and helpful. If you have, check and like and subscribe. Really helps out. It's really appreciated. If you'd like to see me do more ones like this, where I dive into projects that I've built and sort of talk about how I've set things up, share code from them, talk a bit about sort of the design and tech side of it, make some code available there, do let me know. Because there's a lot of ones that could be quite interesting to talk about. Obviously, there's a whole bunch of commercial games that I've done that I can't talk about, but all of the ones that are my own games, I can talk about those ones. So do mention that if there are other ones you'd like to see me talk about that I've done. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below. But until next time, bye.